Hello students, in the previous video we have discussed about preparation of nitric acid and also manufacture of nitric acid. Now we will study the properties of nitric acid. What are the qualities and properties, physical properties, indicator properties and the reactions of dilute as well as concentrated nitric acid in this. So keep watching. Properties of nitric acid. First one is the indicator properties. The indicators are substances which show color change in the acids. So here we have the first indicator, phenolphthalein. Phenolphthalein, which is, if it is pink colored, it has two colors, colorlessness and pink color. Pink to colorless. Pink color phenolphthalein added to dilute nitric acid will change to colorless. Methyl orange. Methyl orange changes from orange to red. Red, or sometimes people call it pink also. So orange to red or pink. This is the color change in methyl orange. And litmus changes from blue to red. This is a color change in litmus. So these are the properties of nitric acid with the indicators. Now dilute nitric acid is a strong monobasic acid. It's a strong acid because it produces high concentration of hydronium ions in aqueous solution, and dilute form has much dilution and full ionization takes place, so it will be a strong acid. And secondly, it is monobasic. One molecule of nitric acid gives one H plus ion, so it is a monobasic acid. So the various reactions of this monobasic acid are here. First one is it reacts with bases to give salt and water only. So this reaction is called a neutralization reaction. Neutralization reaction. Okay. Example, we have the substances here. Sodium hydroxide NaOH plus HNO3 will give the salt NaNO3, sodium nitrate, and water H2O. So this is sodium nitrate. Okay. And the second one, calcium hydroxide is reacting CaOH whole twice plus HNO3. Here we have calcium nitrate CaNO3 whole twice, calcium nitrate plus H2O. Here we need 2 HNO3 and you get 2 H2O. Next, ammonium hydroxide will give ammonium nitrate NH4NO3 and H2O. So this way we get salt and water, calcium nitrate, ammonium nitrate. Okay. And then this nitric acid in the dilute form also reacts with metal carbonates and bicarbonates. Bicarbonates are otherwise called hydrogen carbonates. So to form salt, water and carbon dioxide. Students, what you have to do is learn this statement. What reacts with what and what are the products formed. Don't memorize reactions. And reactions you create yourself. So dilute nitric acid reacts with metal carbonates and bicarbonates, giving salt, water and carbon dioxide. What are the products? Salt, water and carbon dioxide. Now let's write some equations. Okay. So let's take some metal carbonates and bicarbonates. We have the sodium carbonate here, Na2CO3, sodium carbonate, reacting with dilute nitric acid. We have NaNO3, the salt formed is sodium nitrate, and water and carbon dioxide. Okay. So this reaction NaNO3. So 2 NaNO3 will be there because Na2CO3, 2 HNO3 is there. So you have H2O and CO2. Yeah, it's now balanced. Now sodium bicarbonate or NaHCO3 will react. Here you have NaNO3, sodium nitrate is formed again, and H2O and CO2. Okay. This reaction is also balanced. The third reaction is with calcium carbonate, CaNO3 whole twice, calcium nitrate plus water and carbon dioxide. Okay. So 2 HNO3 will be required, H2O and CO2. Yeah, it is also balanced. Calcium bicarbonate, calcium CaHCO3 whole twice, CaNO3 whole twice, calcium nitrate and water, and you have CO2, carbon dioxide. So how do you balance this? 2 HNO3 and 2 H2O and 2 CO2. So it is balanced now. So this is how we get the products in this reaction. Now, since carbon dioxide is evolved in this reaction, what will be the observation? The observation is important. Observation means what you can observe, what you can see, what you can smell, what you can hear. So that is observations, what we can feel with our sense organs. Colorless and odorless gas evolved. Carbon dioxide is colorless and odorless gas. It turns lime water to milky or turbid. And the milkiness or turbidity disappears when excess of the gas is passed. So this is what we know in the laboratory. When we work, we understand it. Lime water turns milky when carbon dioxide is passed. If you pass excess of carbon dioxide, the milkiness disappears. That also we know. And the other testing agent is the potassium dichromate paper or potassium dichromate solution. If you pass carbon dioxide through potassium dichromate solution or potassium dichromate paper is introduced to carbon dioxide, nothing happens. No visible change happens or no characteristic change. Okay, right. The next reaction is dilute nitric acid reacting with metal sulfides and bisulfides. It will produce salt, water and sulfur dioxide. Similar to this reaction, here it is carbon dioxide, but here it will be sulfur dioxide. That is the only change here. So let's write the reaction. Na2SO3 sodium sulfite. This is sodium sulfite. The product will be NaNO3, sodium nitrate, the salt, plus water, and sulfur dioxide is produced here. So 2Na, so 2HNO3 will be there, 2NaNO3. So you get the product here. And then we have sodium hydrogen sulfite or sodium bisulfite is reacting. Here again you get NaNO3 sodium nitrate and water and sulfur dioxide. So sulfur dioxide gas is evolved in both these reactions with sulfite as well as bisulfites. Now, what will be the observation? The sulfur dioxide gas evolved. We have the observation which is colorless gas and it has a pungent odor. Colorless gas with pungent odor is evolved and it turns potassium dichromate paper or solution to green. Lime water turns milky. The same observation. See, carbon dioxide as well as sulfur both will turn lime water milky. At the same time, the potassium dichromate paper or solution makes the difference. Carbon dioxide, there will be no action on potassium dichromate, whereas here it will be the paper or solution will turn green. The original color of the paper is yellow or orange red depending on the concentration. Very dilute solution will be yellow, concentrated will be orange red. Now when it is sulfur dioxide is passed through it or the paper is introduced to sulfur dioxide gas, the final color will be green. So you can write safely from instead of writing yellow to green or orange to green, to write, just write it turns to green. That will be the safe way of writing the answer for this. Let's move to the next reaction. The next reaction is dilute nitric acid reacting with metal sulfide. So right now we have discussed sulfides. Now let us discuss sulfide. So what will happen if metal sulfide is used? In the case of metal sulfide, two products are coming there. That is, it will give salt and hydrogen sulfide only. There are two products. Okay. Now let us take sodium sulfide as an example. Na2S reacting with HNO3. You have NaNO3 sodium nitrate and then you have H2S. Okay, so how do we balance this? There will be 2 NaNO3, 2 HNO3 and H2S. Hydrogen sulfide gas. The gas is hydrogen sulfide H2S. What is the observation? It is a colorless gas with a foul smell of rotten eggs. Smell of rotten eggs. Very foul, unpleasant smell. Now the gas turns lead acetate paper silvery black. A filter paper soaked in lead acetate solution will turn silvery black, and or if you pass the gas through lead acetate solution, you will get a black precipitate. Okay, so that is the fourth reaction. The next fifth reaction is the reaction of dilute nitric acid with metals. Dilute acids usually reacting with metals will give hydrogen. So but dilute nitric acid does not give hydrogen. Other acids give hydrogen, but dilute nitric acid does not give hydrogen. It gives nitrogen monoxide or otherwise called nitric oxide. So the observation is nitrogen monoxide, colorless gas. It's a colorless gas evolved but it turns brown when it comes to the mouth of the test tube. Why? It combines with the oxygen of the air, forming nitrogen dioxide, right? Now let's write the reaction. So copper is reacting with nitric acid. Copper is not an active metal, but it reacts. So CuNO3 whole twice plus H2O, water and nitrogen monoxide. Okay, so how do you balance this one? 3 and 3, 4 and 8 and 2NO. Okay, so nitrogen monoxide is formed. Same way, zinc is an active metal. Zinc also reacts with dilute nitric acid, giving zinc nitrate, and water and nitrogen monoxide or nitric oxide. 2 and 4 and 3 and 8 and 3. So this is balanced. Okay, right? Let us see, this is a product. Now yeah, there are certain things to note here. One is the colorless NO, that is what I already said, that turns to reddish brown NO2 when it comes in contact with air. It changes to nitrogen dioxide. Second is why hydrogen is not evolved in this reaction. The hydrogen formed is oxidized to water in this reaction. The reaction, nitric acid, as we have seen, is a powerful oxidizing agent. It decomposes, producing nascent oxygen, and it will convert the hydrogen form to water. So that is why hydrogen is not evolved in this reaction. Now, however, hydrogen can be obtained if the oxidizing power of the acid can be minimized. How can we do that? We can take very dilute nitric acid, that is 1% solution of nitric acid, and it will give hydrogen while reacting with metals like magnesium or manganese can react with this. Now here what happens, due to much dilution, the oxidizing power of the acid is lost, almost lost due to much dilution. So the hydrogen formed will evolve as hydrogen without getting oxidized to water. So let's write the reaction. MgNO3 whole twice is formed, plus hydrogen is evolved in this reaction, 2HNO3. Okay. Now here the observation will be colorless gas burns with a pop sound when a glowing splint is introduced to it. Hydrogen is the gas evolved. Hydrogen is colorless, odorless, but if you introduce a glowing splint, it will burn with a pop sound. It gives a pop sound. So that will show hydrogen is evolved. Now we have the reactions of the concentrated nitric acid. Concentrated nitric acid is a powerful oxidizing agent, a strong oxidizing agent, as we already know. So it will decompose to give nascent oxygen. That is a point to note here. It will decompose to give nascent oxygen. Example, HNO3 when decompose will give you H2O plus NO2 plus O, nascent oxygen. Nascent oxygen is evolved. So 2HNO3 will give. Okay, this nascent oxygen is responsible for the oxidizing reactions. It oxidizes metals as well as non-metals. In your syllabus, we have copper metal, two non-metals, carbon and sulfur. Let's see the reaction. Copper reacting with concentrated nitric acid. This is concentrated. So you have copper nitrate, CuNO3 whole twice formed, plus you have water, and you have nitrogen dioxide obtained in this reaction. So you check the reaction, copper nitrate, water and nitrogen dioxide. So we will balance it, 2H2O and 2NO2. So this is how it is balanced. It needs heat. Heating is required. Again, concentrated nitric acid with carbon, when heated, you have carbon dioxide plus water and nitrogen dioxide. So 4HNO3, 2H2O and 4NO2. Okay. So this is how you get this carbon dioxide, water and nitrogen dioxide. Then we have sulfur. Sulfur when heated with concentrated nitric acid will give you H2SO4 plus H2O plus NO2, nitrogen dioxide. Okay, sulfur, H2SO4, 2H2O and 6HNO3 and 6NO2. Okay, so it will produce sulfuric acid. So sulfur is oxidized to sulfuric acid directly. So question can be asked, which substance can oxidize sulfur to sulfuric acid? So it is concentrated nitric acid is the answer. So students, I hope you understood this, the reactions of nitric acid, dilute as well as concentrated. If you have questions, please write in the comment section. You may like and subscribe the video. Thank you.